Okay, so I'm going to continue working on it, and I hope you're used to this split view. That way I can show the problem and how you do it. That's a little bit too thin, so let's try. So that's part A. What happened to part B? Part B, we're looking for the moment about the point due to cable AB. So refresh your memory, moment O is R cross F. The question is, there are two options of R. Which R are we looking at? We can do, since we're looking at tension in cable AB, we can either do OA or OB. OB seems easier, so I'm going to do that. And my force vector, this is where a lot of you are having problems. The force vector is going to equal to the magnitude of the force vector multiplied by lambda. And the magnitude of the force vector is given in the problem, which is for 517 Newton. And lambda is given as RAB in its magnitude, right? AB. This is a key concept I'm going to highlight. This is where a lot of you missed. A lot of you simply just took the position vectors and cross them with each other. No, you're supposed to be crossing the position vector with the force vector. So this is an area of common mistake, and I just want to show you what that is. So it's 570 I'm simply copying what I found in my part A and divided by the magnitude, which is 1140. Okay, and what is ROB? ROB is very simple. It's from O to B. This is another area I'm going to highlight. A lot of you made a mistake. The position vector needs to be from the point to the force, not from the force to the point. Okay, so take a look at the exam and see if you made that mistake. So ROB then is a positive 900I. And if we go ahead and finish off the tension vector, it's going to equal to 450I, 300J, 80K. And we're going to be crossing each other off. So here's my moment vector O. Another problem I have with you guys, a lot of you did not write down the procedure or how you cross it. You simply show me what the answer is. In the future, I want you to tell me, or at least show me the steps. Like, okay, how did you set up this position vector? So it's 900, 0, 0, 450, minus 300, minus 180. A couple of you made a mistake when you crossed it. Make sure that when you're doing cross product, you're doing this right. So this is going to equal to 1620000J minus 270000K. And don't forget the unit. So that's my answer in part B. Now, part C, I wanted to give the points away. Apparently you couldn't. A lot of you took the long route. But at least you recognize that it's supposed to be a triple product, right? The moment about line OD is the unit vector cross dotted with R cross F. Which F are we talking about? Tension AB? Which R are we looking at? OB. Biggest problem you have? A lot of you, instead of using the unit vector, you use the position vector. Don't forget, this has to be the unit vector. If you go ahead and use the unit vector, you will discover what? What is OD? Lambda OD is equal to R OD divided by its magnitude. It is actually the k-axis. So And I hope you recognize this is the same answer as part B, right? So this is actually equal to k dotted with what exactly am I looking for? Actually, I'm looking for the k component of the moment vector we've done before. So the answer is 270000. Yep, it's that simple. A lot of you went to the long route, spent a lot of time calculating, where this is the easy 10 points. Okay? So